Good. All righty. We left off last time talking about factoring of and factoring we learned from the distributive property. That's the distributive property. Going this way is factoring. So basically what it does, it takes an equation and breaks it down to smaller pieces. Because the whole goal of factoring is to break down the polynomial, the function, down to linear equations. We need to break down equations into smaller linear functions. That's the whole purpose. Why do we need to know that? Is because once we get down to a linear equation like x plus 3, if we set that equal to 0, we can solve for it. So x is equal to -3. So that's our entire objective. This is what we spent chapter 1 on doing. Binomial equations. What does binomial mean? Two terms. This will be the first one we're going to address. If you have binomial equations, two things can occur. Both terms have a variable, or only the exponentiated term is a variable. And I'll show you what that means in a second. It means the only part of the equation that has an exponent is the variable. So let's look at these. Let's look at the first one. 4x squared plus 5x. Whenever we solve equations, we set it equal to 0. Why do we do that? When you set an equation equal to 0, what are you solving for? Let's see if you remember this from chapter 1. Nope. Yeah. What is it though? What is you solving for? Yes, it is x. Very good. Yes. But what is it? What does the x value represent? So what is the solution? You solve for x, but what does that mean? What does that x represent? It's your x-intercept. Just think about it. The equation, if you set it equal to 0, that means the y is equal to what? 0. Whenever you set y equal to 0, the x values are the x-intercepts. So when you have an equation and you solve for the x values, we're also looking for what's called a 0. The reason it's called a 0 is because if you take that x value, put it back into the equation, and work it out, it'll equal 0. That's why it's called a 0. The solutions are also factors. How do we get the solution? We have to factor the equation out. Another name is the roots. The roots of a function or an equation are the x values that make it equal 0. All of these mean the same thing. But they're represented differently. And we'll go over that. So, in order to solve this one, if both terms have the variables, how do we solve it? Let's make it 8x, make it nicer for us. 4x squared plus 8x equals 0. If both terms have x's, what do we have to do? So remember, we can't solve it right now because it has a square and there are two x's. So what can we do? This is where factoring comes in. What do they both have in common? Both of these terms, what do they both have in common? That it? This one is 4x squared. What is 8 made up of? 2 times 4, x. Now what do they both have in common?
2 and
No.
a 4 and a.
They both have a 4, and they have at least one x. Whenever you factor something, if like these x's, it always has to be the smallest number of x's that they have in common. Can you take out two x's out of this equation? No, this one has 2, this one only has 1. So you can only factor out the smallest number of variables. So we took out a 4 and an x. So here's the easiest way. Whenever you do factoring, to see what goes inside here, divide all of these by what you factored out. The 4's cancel. One of my x's cancel. The 4's cancel and the x cancel. So what do I have left in this equation on top? I have an x plus 2. So there's my factored portion of it. Remember, what kind of equation is this? From the library functions, what kind of equation is this? Well, yeah, but that's not the type. It's got a square. Always look at the exponent. The exponent tells you what kind of equation is it. So if it has a 2 as an exponent, what kind is it? Quadratic. Remember, this is the degree. And look at your notes. The degree tells you how many solutions you're supposed to get. Once we factor them out, what do we do? Well, by the zero product principle, whenever two numbers are multiplied together and they equal 0, what has to be true? Either one of them or both of them have to be 0 for it to be 0. Anything times 0 is 0. So here we have two equations. It has to equal 0. So what has to be true? Anything that has an x, we set it equal to 0. According to the zero product principle. And then we solve for x. The first one we divide by 4, so x is equal to 0. Subtract 2, so x equals -2. These are my two solutions. Those are my solutions. In essence, these are what we really call zeros. Why are they called zeros? If we plug 0 back into the original equation, what is it going to equal? 0. If we plug in -2 back in the original equation, it'll equal 0. So that's why these are called zeros. How do we represent them as x-intercepts? They're x-intercepts. How do we represent them as x-intercepts? What are x-intercepts? Well, yeah. But an x-intercept is the location where the graph crosses the x-axis. It's a point. So yes, it has to be so the x value is 0, y is going to be 0. When x is -2, y is going to be, so that's how you represent the x-intercept. All right, so that's if you have two terms and they both have variables. Next, if we have two terms and only one of them has if we have two terms and only one of them has an x, it's still a binomial, but only one term has a variable. So this one is only one term has a variable. And it's usually the term that has the highest exponent. So how do you solve it? To solve, we use the square root method. What does that mean? First off, isolate, since there's only one x value here, you have to isolate the x value. How do you do that? How do you get the x by itself? Adding 4 to both sides. So we have x squared equals 4. Now we're solving for x. What do we have to get rid of? How do you get rid of the exponent? It's a square. So we square root both sides. The square root and the square cancel, so we have x. And what do we put on the other side? You have to put whenever you have an even exponent, you have to put a plus or minus in front of the answer. Then what's the square root of 4? 2. So that's your answer. Those are my zeros. Because if I plugged in 2 and -2 inside here, it would equal 0. What would my x-intercept look like? How many x-intercepts do I have? It has to be 2. So the first one is going to have +2. The next one is going to have -2. And the y's have to be 0 since they're x-intercepts. So that's the first way if we only have binomials. Because if you remember this, we're dealing with quadratic equations. What do quadratic equations look like? What's the formula for a quadratic equation? In standard form, it looks like this. That's a quadratic equation. How do we know it's quadratic? exponent. The biggest exponent is 2. So typically, whenever you set up an equation, whatever the highest exponent, you have to have all the other exponents down to 0. This is x2, this is x1, this one's x0. If my highest exponent was x to the 5th, then I have to have x to the 4th, x to the 3rd, x to the squared, x to the 1, and no x's. You always had that many equations. Now, to solve quadratic equations, we have 3 methods. One is by factoring. The next method is complete the square. And the last method is the quadratic formula. We've done factoring already on binomials. And we could do the rest of these, but it's much easier when we have 3 terms. So factoring. Again, whenever you have, these are called polynomials, which means it has many terms. In this case, in this chapter, we're only dealing with polynomials, with quadratics, with a power of 2. Whenever you do this, the first thing you have to do is set it equal to 0. That's always your first step. Set it equal to 0. Now, for this first part, we're only going to look at equations where let me see. This term here is called the leading term. Because it's the first one. It's the term that has the highest exponent. This term back here is called the constant term because it has no x value. It's a constant number. It never changes. With the leading term, the A, this part here is called the leading coefficient. The number in front of the x squared is called the leading coefficient. And the constant term is also called the y-intercept. So in our first set of factoring, we're going to look at our leading term equals to 1. Because these are the most easy. So we have this example. Actually, before we jump into this, multiply all of these together. Multiply these 4 together. So in the first one, what do I mean by when I say multiply? How do we multiply these together? What method do we use? And FOIL, but it's really distributivity. FOIL only works in binomials, but we can do this with any size equation we want to. So it's distributivity. Everything in the first parenthesis has to multiply to everything in the second. That's what distributivity is all about. So x times x is x squared. Positive times positive is positive. X times 3 is 3x. That does it with that one. Positive times positive is positive. 2 times x is 2x. Positive times positive is positive. 2 times 3 is 6. Combine like terms. Positive, positive, so we add the numbers. 2 plus 3 is 5. We get that. Do the other three. And for time's sake, I'm going to work them with you. I mean, if you don't know how to do these, again, you have to learn how to do these. Actually, I'll let y'all have a little bit of time yourselves to do it. So the next one, x times x is x squared. Positive times negative is negative. X times 3 is 3x. So that's that one. Positive and positive is a positive. 2 times x is 2x. Positive times negative is negative. 2 times 3 is 6. Combine like terms. Negative 3 and positive 2. 3 is bigger, so the answer is negative. 3 minus 2 is 1. Minus 6. That's the next one. X times x is x squared. Positive times positive is positive. X times 3 is 3x. That's that one. Negative times positive is negative. 2 times x is 2x. Negative times positive is negative. 2 times 3 is 6. Combine like terms. So we have x squared. Positive 3 minus 2. 3 is bigger, so the answer is positive. 3 minus 2 is 1, so it's just x. And the last one, x times x is x squared. Positive times negative is negative. X times 3 is 3x. Negative times positive is negative. 2 times x is 2x. Negative times negative is positive. 2 times 3 is 6. Combine like terms. They're both negatives. So the answer is negative. Add the numbers. So if you're spending all your time copying this, you really should spend this weekend practicing how to do this. It's not difficult. It's just multiplying one number, set of numbers to another set of numbers. If you're spending all your time copying this, then we have issues. Now, the reason this is important is because depending on the equation I give you, for example, if I say x squared minus 6x minus 10 equals 0. Now, what is the directions of this question? What is it asking us to find, even if there's no words there? Is it a function or an equation? Why is it an equation? There's an equal sign, so it's an equation. What do you do with equations? Whenever you have equations, what do? You solve them. So without being written there, because it has an equal sign, it automatically tells you solve this equation. So when it says solve, that means find me the x values. So step 1. set equal to 0. Check. Put your 2 parentheses down. Because the only way we can solve this is by factoring it. So look at the first part. Where does this x squared come from? Look at the things we just did, or the one things you watched me do. Where did the x squared come from? Very good. And where were those x's? Perfect. That's exactly right. So it's this first term came from the first spaces inside the parentheses. Put x's in the first spots. So we did that, x and x. So that equals the first one. The next thing we look at the second sign. What is the second sign in this example? What's the second sign? Yeah. What's the first sign? This is the first sign. This is the second sign. Now, look at the second sign. If it's positive, then both signs are the same. And they are the first sign. So if the second sign is a plus, then the signs are the same. They're whatever the first sign is. If the second sign is a minus, then the signs are opposite. One's positive, one's negative. And the bigger number will get the first sign. Now, what does all that stuff mean? Looking at the signs. If the signs inside the parentheses are the same, then they're whatever the first sign is. If they're opposite, then the first sign, the second sign is going to be minus, but the first sign will be whatever the bigger number is. I'll show you what that means. Here we have a plus sign. What is that going to tell us about our equations? That means the second sign is positive. That means both signs are same. They're both going to be positive. Well, sure enough, look at our equation. It came from x plus 2, x plus 3. So if the second sign is a positive, that means they're the same sign. It's whatever the first sign is. These signs are both positive. Look at this last one. The second sign is a minus. So then that means they're the same sign. They're both going to be minus. So we have x minus, x minus. If the second sign is a minus, then they're opposites. If the second sign's a minus, one of them is going to have a plus, one's going to have a minus. Remember, since this is x squared, x goes in first. X next. So far, so good. Everything's good there. So in this case, what are the signs going to be? Yeah, since the second sign's a minus, they're going to be opposites. One's going to be positive, one's going to be negative. Now, in these spaces, that's where the numbers go. The next step. Find two numbers that multiply to equal the third term and when you second sign them, you get the middle term. Put your phone away. Oh. So what does that mean? So we did the signs. Then next we do is find the numbers. Find two numbers that multiply to equal the third. So we have to find two numbers that when we multiply equal 10. That's what this says. Find two numbers that when you multiply equal to the third term. This is the third term. That when you second sign them, you get the middle term. So here's the second sign. So some number minus another number has to equal 6. So are there two numbers that equal this? What two numbers equal 10 that when we subtract them, we get 6? Let's make it a little bit easier then. Let's make this one 3. Because the first one had to crawl before we could run. So find two numbers that equal to the third term that when we subtract them, we get the middle term. So what two numbers equal 10 when we multiply them? So 5 times 2. When we subtract them, do they equal 3? Yes. So 5 and 2 are our numbers. So where does the 5 go? According to this, well, we have to put that. I put it over here. If the second sign is a minus, the signs are opposite, and the bigger number will get the first sign. I already put it in there. The second sign's a minus. So the bigger number will get the negative sign. So the 5 goes there and the 2 goes there. That's factoring. Now, step 6 is solve. Set them equal to 0 and solve. So here we take these equations here. So we have x plus 2, set it equals 0. X minus 5 equals 0. These are my solutions. Step 7 is check your answer. CYA. Always check your answer. Because we're going to be looking at some of these examples where only one of them will work. The other one won't. So how do you check your answer? Go back to the original equation. X squared minus 3x minus 10 equals 0. Plug in negative 2. Negative 2 squared, 3 times negative 2 minus 10. Negative 2 squared is positive 4. Negative and negative is a positive. 3 times 2 is 6. Minus 10. So 6 plus 4 is 10. 10 minus 10 is 0. So that's a good solution. And do the same thing again. Plug that next equation, the x equals 5, into the original equation. 5 squared minus 3 times 5 minus 10. 5 squared is 25. Negative times positive is negative. 3 times 5 is 15. Minus 10. 25 minus 15 is 10. 10 minus 10 is 0. So those are my two solutions. All right, let's look at another example. What if we had this? What are my steps telling me to do first? What's my first step? Set it equal to 0. Okay, no more. I want to see if anybody else in this room is even awake. Because I haven't heard anything from most of these people here. Because remember, we also have the second hour of this class, which I can keep you in for the second hour if nobody answers questions. I could wait forever. So start participating. What's my first step? Well, the first step set equals 0. The next step would be the parentheses. Then what? Put in the X's. Yeah, from now on, I'm gonna have y'all go to the board. I'm gonna start picking one person, they go to the board and they'll pick the next person, because this is ridiculous. What's the next step? And what does that tell me? What does that mean? One's gonna be positive, one's gonna be negative. That's all this sign tells me. One's gonna be positive, one's gonna be negative. What's my next step? Well, what else is it? What is that same step? What else does it tell me? Which is, so the first sign is positive, so the larger number will go here. What's my next step? What's my next step? So, which are they gonna be? So tell me what to write. Tell me what to write. Because all you did was read it out to me. We got two numbers that when you do what? When you multiply, what does it equal? Which is, are you asking me or telling me? You're thinking it's 6. Can anybody help her? Anybody more confident? Because this is the last question where everybody's working together. From now on, you're going to the board. Everybody's gonna get a chance to do one problem before we move on to the next topic. Not -6, just the term 6. And then what else? Okay, we know what two numbers multiply give you the third term, then what?
Those same two numbers multiply, subtract, it gives you the number.
Why subtracted?
Because then you do the second sign.
Very good. Because the second sign's a minus, so we gotta figure out what two numbers, when you subtract them, equals what? Why 1?
Because that's the implied number.
That's very good, very good. So this is the only part you have to think about. And I'm eager to see what you guys do when you go to the board. So what numbers go in there? 3 times 2 is 6. 3 minus 2 is 1. Check. So which number goes there? And that means the 2 goes there. How would you check that? To see if it's right? No. In this entire course, you don't have to use a calculator once. Just use your brain. How would you check to see if this is right? And how would you use a calculator to check it? You can't use a calculator there. Can anybody guess how would you would check to see that's the right factor?
Distribute.
Multiply these two together and see if you end up with this. X times X is X squared, negative 2X, positive 3X, negative 6. X squared, positive 1X minus 6, they're the same. So that's a good factor. Very good. Now what do we do to find our solutions? Because we're not done until what? We're not done until we solve it. Solving means we have to solve for X. So how do we solve for X? What do we do to solve for X? Which ones? Right. You take these, the factored forms, set them both equal to 0. Very good. And then you solve for them. What do you get? If you've noticed, or if you've been paying attention, the answer from this factored form to the answer is always the opposite number. If it's x plus 2, the answer is negative 3. If it's x minus 2, it's positive 2. So it's always the opposite of what's inside the equation. We learned that in chapter 2, the transformations. And then you check them. I'll let you check them. All right. So let me give you some examples here. And since you spoke the most, you can pick the next person. Because, yeah, you pick the next person, then they'll pick the next person, and then they'll pick the next person. So everybody's going to pick somebody else to be mad at them.
Oh, okay.